Tires, one of the key components of a car affecting safety and efficiency. But how do you create the perfect tire for the road and for the racetrack?
It's work that has a lot of responsibility. I can't switch off mentally. I have to always be on the ball.
It takes 100 constituents, 15 manufacturing steps, and over 50 performance tests undertaken in high-tech laboratories. Only then will the P0, Pirelli's flagship product, take to the streets of the world.
When it comes to the manufacturing process, we're talking about a machine that has to perform flawlessly.
And this is only made possible thanks to Mega Manufacturing. Perfect in every detail. Turin, Italy, production plant of the most famous tire manufacturer in the world. Each day, 1,200 workers at the factory manufacture thousands of the high-performance P0 tires for the road, and for Formula One, too. A tire that can withstand the toughest of challenges and is trusted by the world's leading car manufacturers and race car drivers. A tire that's so much more than simply rubber. A high-tech product with complex internals involving around 100 starting materials, processed into about 8 component parts. And everything is tuned to the requirements of individual car models. True mega manufacturing. And it all begins here at the Turin factory. The P0 is born in Building A. Eight o'clock in the morning, the first trucks deliver the raw materials for a world-class tire. The most important ingredient? Natural rubber. The basic raw material for around 130 years. Around 70% of the global rubber harvest is used to manufacture tires. Plant manager Alessio Secchi regularly verifies the acceptance of the shipment.
Ciao Antonio, good morning.
Good morning.
Everything okay?
Yes, the rubber shipment from Indonesia has just arrived.
Natural rubber is made from liquid latex harvested from rubber trees. They're grown predominantly in the so-called rubber belt surrounding the equator, which includes Indonesia. The quality and variety are decisive for the future rubber compound.
Dozens of trucks arrive here every day. They come loaded with dozens of tons of very different materials. We have to then process them correctly. This is done according to the first-in, first-out principle. This means that whatever arrives first is processed first, and everything is traceable, so we can not only tell where the raw materials come from, but what the quality is too.
The natural rubber is still highly temperature sensitive, rock hard when cold, and soft and sticky when warm. Not exactly desirable properties for a tire. A key step at the end of production turns this sticky mass into the elastic rubber so vital for tires. But not all rubber is the same. Different types of rubber are used depending on the type of tire, summer or winter, Formula One car or sedan, and rubbers made in the laboratory too. The advantage of the white synthetic rubber is that its properties can be designed in the lab, specific to the rubber compound's eventual use.
The rubber compound plays a key role in tire manufacture. There are at least 10 different compounds in a tire, and we need at least 20 ingredients to make each compound.
And all with the single goal of creating the perfect tire, whether for the road or the racetrack, and achieving the best possible compromise between three irreconcilable and contradictory properties: low rolling resistance, strong grip, and low wear. The secrets of this mega manufacturing operation lie on the other ingredients too: a precisely measured blend of fillers, antioxidants, plasticizers, and curing agents. These include, for example, oils, resins, and carbon black. Only with their help is it possible to reconcile the various contradictory properties in a single tire. Maximum grip in all weather conditions, combined with minimal rolling resistance and wear. All raw materials have to be analyzed in the factory laboratory. Any inferior ingredients would jeopardize the quality of the final product. 30 employees work in 3 shifts here. Their job, nothing short of ensuring the quality of umpteen thousand tires every day. Laboratory technician Giuseppe Brancati is checking the quality of today's carbon black delivery.
I'm checking the iodine content of the carbon black. We do this for each delivery. We check all of the raw materials in order to guarantee the future quality of our P0s.
Carbon black extends the lifespan of the tires. The laboratory technicians use an iodine solution to assess its surface structure and thereby its efficacy.
We use a variety of tests to check the quality of the raw materials. We analyze the materials using infrared or by checking their melting point. The compound for the tire will only be right if the raw materials remain consistent. There are other departments in the laboratory where we analyze the final rubber compound, for instance. We analyze everything from the start to the end of production.
20,000 laboratory tests are performed each month to ensure maximum performance on the road. The tested starting materials continue their journey in building A. The next step, to perfectly blend all of the ingredients. An enormous machine with internal rollers blends the ingredients into a homogeneous mass for a few minutes at more than 150 degrees Celsius. But the perfect manufacturing process is only one half of the company's recipe for success. The other, the workforce. Walter Saita has been working at the plant for 25 years.
I've worked in many departments over the years, but I moved here at my own request. It's not my thing to be in just one place all the time. I'm like a jack of all trades and can be assigned anywhere. And I've trained a lot of new colleagues over the years as a result.
Walter's task, to create the perfect rubber for the perfect tire. The basic conflict: if the compound is too soft, the tire will grip well, but wear too quickly. Harder compounds will last longer, but provide less traction control. This is why it takes more than a single compound. Up to 10 different rubber compounds are required for different zones of the tire. A car tire is a complex high-tech product with many individual layers. The airtight inner liner, what used to be the inner tube, bonded with woven textile fibers in the carcass, the main body of the tire. Steel wires embedded in rubber form the steel belt. And the outermost layer, the tread, that makes contact with the road surface. It's what determines how well the tire grips the road. Tires have to withstand extreme stresses, and they mustn't lose traction under any circumstances. Ultimately, it's all about passenger safety. The various rubber compounds continue their journey in building B. This is where the individual components of the P0 are fabricated. It's also when the future tread pattern is prepared. The rubber sheets are made into the tread. A complex process that requires little human involvement nowadays. It, on the other hand, has a key role to play: the extruder, a largely computer-controlled machine that transforms the rubber compounds into treads. The rubber is heated to around 100 degrees Celsius to make it malleable. An internal screw then forces it through the die. The workers monitor the various processes within the 50-meter-long machine. Stefano Testi supervises the production operation. He's tasked with ensuring continuous improvement in the production process.
In this section, we produce the tread that will affect the future tire's traction, grip, and rolling resistance, and thus the overall handling characteristics of the car.
Only when all of the processes are working in perfect harmony will the extruder output the ideal tread, creating that magic combination of maximum grip and minimal rolling resistance. The extruder has blended various rubber compounds to form a single tread. In order to trace which compounds are in which treads, every single one is assigned a number. Creating the perfect tire, whether for the road or for Formula One, requires perfect mega manufacturing. The first stage of the manufacturing process is complete. 100 meters of tread will soon form a part of the new P0s, the ultimate car tire, whose properties are being constantly refined 140 kilometers away in Milan. The headquarters of the Research and Development Department. 1,900 engineers in different countries work on optimization processes. The upshot? Over 200 million euros spent on research each year. Andrea Vergani is one of the managers of the development department. He supervises prototype production. The tread is an aspect that developers in Milan focus on too. A tread design optimized on the computer is about to be applied to a prototype.
I've entered all the data. We need the same method as before. We start by scanning the surface. Before, we never knew exactly where the laser would hit.
The machine helps the team to develop or improve tire treads.
It's a special laser drawing machine. We can use the laser to trace the outlines on a smooth tire. This is how we make the prototypes for a new tread line that will later be produced by the thousands.
Although the machine is fully automated, Andrea and his colleague still have to monitor the process. The laser burns black lines into the white painted tire. The lines are made where the grooves of the tread will be later. There's a fundamental conflict when it comes to the tread pattern too. To achieve good cornering and braking characteristics on dry roads, the contact patch needs to be as large as possible. But for optimal water displacement, in order to prevent aquaplaning, the opposite is true. For this reason, the P0's tread design consists of 3 elements, with wide longitudinal grooves that can rapidly displace water, an S-shaped design that increases safety during critical braking maneuvers, and 3 solid central ribs. They improve braking and traction at high speeds. The next step isn't reliant on technology, but craftsmanship. The sciabiatori, or cutters, finish the tread on the prototypes using special tools and a variety of widths.
What are you working on at the moment?
I'm making a beautiful cut.
This is the cut for an all-season tire that ensures safe driving in wet and dry conditions the year round.
Paolo Tona is proud to be involved in creating new car tires.
When I'm out and about, I'm always checking out other tires. I look at what the competition is doing or see what we've developed in the past. This is where projects like a new P0 begin. We make the prototypes here. The tire then goes to the development department. The product is brought to market, and I get to see the tires on cars. I think that's really cool.
Cutting the tread of a tire can take up to 20 work hours. The advantage of the handmade prototypes? The developers can change the tread design more quickly, following initial testing results, if it turns out to be too loud, for instance. The tread pattern also influences noise. As a rule, the more aggressive the tread pattern, the more noise. The research team attempts to optimize this aspect as well, because significant component of traffic noise is caused by the tires. Maurizio Mauro tests in an anechoic chamber. Sound isn't reflected by the walls in here. It allows conditions that closely simulate the real environment to be artificially created in the lab. And all with the single goal of making the perfect tire as quiet as possible.
We used to bring cars in here and do the test with the vehicles in situ. We measured the noise levels inside and outside the vehicle. Nowadays, we can achieve the same results with this torretta machine. That means little tower.
The use of cutting-edge technology here helps reduce research costs too.
This test involves a speed drop from 150 to 20 kilometers per hour. The speed of the tire is displayed on this monitor here. We can see the microphones here. One on one side of the tread track and one on the back side. This allows us to check noise emission at both speeds.
Even for cars with combustion engines, the biggest part of the noise results from the tires alone. For electric vehicles, it's even greater. To make the tires roll as quietly as possible, the developers usually arrange the tread blocks at a slight angle to the rolling direction. This is true for the P0 as well, whose manufacture continues with maximum efficiency in Turin. Mega manufacturing of a high-tech car tire in a factory that consumes as much energy as around 1,000 homes. In Building B, over 1 kilometer of metal cords go into each tire. Its job, to lend the tire stability, even under extreme conditions. The steel belt sits directly beneath the tread and cap plies. 2 layers are laid on top of one another so that the metal fibers are at an angle of approximately 30 degrees, which forms the so-called radial tire. A milestone in tire development. The steel wire is plated with brass in order to protect against rust and help it bond with the rubber.
Tires are a complex product. They're reinforced internally with fabric and metal cords. Before the metal cords can be processed, they first have to be embedded in rubber. This is what the so-called calendar does.
Car tires have to take a lot of punishment. How does the manufacturing team minimize wear, even when performing extreme driving maneuvers? How is rolling resistance reduced? The steel belt makes this all possible. In order for the steel cord to bond properly with the rest of the tire, it has to be coated with rubber. This is done by the calendar, a machine consisting of several heated steel rollers. They ensure that components fuse together properly.
Once the metal cord has been encased in rubber, it's cut by the machine. This sheet will later form the steel belt we'll need to manufacture our P0s.
Another important component of the P0 rolls off the production line and now has to be cut to length. And getting the cut right is crucial. It should be angled so that the fibers in the finished tire run perpendicular to the direction of travel. This is necessary for the steel belt to withstand high speeds. A similar process is used to create the fabric rubber composites used on the insides of the tire, the carcass. This also gives the tire its stability. And all this is the result of an unceasing research program, 140 kilometers away in the Milan Research Department. The prototype tire is pushed to its limits. Today, a P0 for Formula One is on the high-speed test rig. The tire must withstand speeds of up to 400 kilometers per hour and temperatures of over 100 degrees Celsius. The technicians painstakingly analyze every variation in performance. The research team has just one mission: to constantly refine the P0. The valuable lessons that Pirelli learns from the P0 used in motorsports eventually benefit all customers. Piero Missani, Senior Vice President for Research and Development, has worked for Pirelli for 30 years. He and his team are responsible for every innovation regarding the P0.
It isn't sufficient to just meet the general requirements of the car manufacturers. We always adapt the tire for the individual car models. As such, the customer can always get what they need.
There isn't actually just one P0. Marked on the side wall is the tire size, abbreviation for the construction type, and recommended speed category. Some car manufacturers get a tire tailor-made for their models, be it for the racetrack or the road. The developers tune the tires to complement the car in parallel to its development. The so-called flat track test assists in this process. Piero Missani makes a flying visit. He supervises all of the tests performed by his staff. His team is laying the foundations for the innovations of tomorrow.
What kind is this?
It's a GT Motorsport tire, 325/70/18.
Let's see what the X-ray examination says.
For most of its 150-year history, Pirelli tested and optimized all of its tires on the test track. Today, indoor testing results in time savings and delivers more accurate results, obtained on a test rig that's just 10 by 10 meters in size.
Here we can simultaneously see all the parameters for the tire mounted on the machine, such as speed, vertical forces, torque, temperature, and pressure. This is a sophisticated piece of equipment. We can use it to view all of the physical measurements on the monitor during the test.
This is all part of Pirelli's custom manufacturing process for the P0. The computer uses all of the analyzed data to create a virtual tire almost in real time.
Based on the information from the sensors fitted to the machine, we construct a model of the tire that's transferred to a driving simulator along with a model of the car. We can then monitor everything on the driving simulator as if the tire were on a test track. This greatly reduces development time. The upshot, we can design the ideal tire for a car that's still in development. This is a much more efficient approach.
The team uses this technique to develop tires for general sale, as well as custom products, specially tailored to the needs of car manufacturers for their latest models. For every type of vehicle, from a Formula One car to a sedan. And that's by no means the end of the story. Piero Missani and his development team are already working on the tire of the future.
We've designed some cyber concepts. For example, we have an intelligent tire that can communicate. A tire can pass on so much information. After all, it's the only part of a vehicle actually in contact with the road. A tire can reveal a great deal of information about itself and data about where it's going. And this information is vital for safety.
Advancements that were unthinkable when the company was founded. In 1872, Giovanni Battista Pirelli established a rubber factory for manufacturing telegraph cables and bicycle tires. Pirelli began manufacturing car tires in 1901 and made its first foray into motorsports at the Paris-Peking race just 6 years later. The company is now the exclusive tire supplier to various motor racing series, including the most exacting test in the world of motoring, Formula One. Here, its rubber compounds often make the difference between winning and losing.
We love challenges and innovations. They keep us at the forefront of the world of motorsports. We're constantly developing new technologies for motor racing that quickly end up with our customers. We're the official tire suppliers to top championships such as Formula One and Superbike for motorbikes. The P0 family represents the link between motorsports on the racetrack and the motorist in everyday life.
Today, the company is the leading tire manufacturer in the prestige segment and is gearing up for the future. High-tech plants are already producing the Formula One tire of tomorrow today, and in the not-too-distant future for the road, too. Robots represent the future of tire production, working more accurately and with increased energy and CO2 efficiency, key concerns for the motor industry in general. Mega manufacturing at the highest level. Meanwhile, in Building A, the process of fusing the individual components together, so-called building, is underway. Only if all of the components complement one another perfectly will a tire be produced that can meet all of the demands. An airtight layer of rubber is wrapped around the drum. This inner liner does the job of the former inner tube. Next up is the carcass, the supporting structure of the tire. It consists of rubberized textile fibers. The beads ensure the tire sits securely on the wheel rim. The side walls are made from flexible rubber to improve ride comfort. Another machine applies two steel belts. They ensure stability and protection. And on the outside, the tread. The tread pattern and composition determine the level of grip, wear, and rolling resistance. In the final step, the inner and outer parts of the tire are fused together. All this happens very quickly. First, the inner liner is placed on the drum. Then, the carcass. Followed by the beads. together with the sidewalls. These parts form the basic structure of the tire. Meanwhile, another part of the machine joins two steel belts together and wraps them with nylon. The belts increase stability. The treads are placed on top. Now, they're ready to be united. The belts and carcass celebrate their marriage. The so-called green tire is finished. It looks almost like a tire, but still has no tread pattern and is neither elastic nor especially durable. Giuseppe Gallo sticks a final barcode onto the P0. Even after many years at the company, he's still proud to work at this station.
My team leader and my colleagues have all done a great job showing me the ropes. Believe it or not, there's always something new to learn here about how you can do something even better. It's work that has a lot of responsibility. I can't switch off mentally. I always have to be on the ball.
A few steps later, the vulcanization takes place. Now the rubber and green tire will be turned into a finished P0. The machine fuses all of the components together at a temperature of more than 150 degrees and a pressure of more than 15 bar.
There's a pressure bladder inside that inflates and presses the all-green tire on the mold. The tread is pressed inside the mold, which is engraved with the tread pattern. During the vulcanization process, the soft material is transformed into elastic rubber.
The smooth rubber blank has become a tire with a unique tread pattern. The tire only gets its final shape during the last step. The P0 has almost reached the finish line. All that's left are the final inspections. These are undertaken at Finishing and Building B. As at all the other stations, the workers here have to maintain strict quality standards. The procedure is always similar. It starts with a visual and tactile inspection. Special attention is paid to the internal areas, which must later make perfect contact with the rim. The worker scrapes off even the smallest pieces of surplus rubber and examines the inside of the tire. All of the components that make up the carcass must be perfectly positioned.
The first step during finishing is the visual inspection. We train our workers continually. They can tell at a glance if there are small irregularities on the surface. They're often merely aesthetic issues.
Stiamo parlando di difetti che possono essere puramente estetici.
But our P0 should not only perform great on the road, but look perfect too.
Only when the inspector gives the green light can the high-tech tire proceed to the next station. The diameter and width of the P0 are defined with millimeter precision. An X-ray machine checks the internal metal construction. Only afterwards may the tire fulfill its destiny, making contact with the roads of the world. The tread is the star of the show at this station too. The X-ray unit reveals any flaw.
This unit is called shearography. We use it to inspect the tread and sidewalls. we check whether there are air pockets on the surface or if the steel belts have become detached. This is the first automatic inspection. Then it goes to the X-ray unit. There we inspect the tire and the belt once again, the sidewalls, the bead assembly, the entire surface of the tire, actually.
Giuseppina Chiari started working here immediately after leaving school.
I actually come from the first station, so used to work at semi-finishing. Now, I've moved to the end of the manufacturing process, to inspections. I enjoy the work, and Formula One too. I watch Formula 3 and X-races too, especially when Pirelli equips the cars with our tires.
The P0 on its way to the final inspection. This machine conducts a multi-stage test of the tires. For example, checking whether an imbalance has developed during production. This can not only negatively impact its handling characteristics, but result in uneven tread wear too. Each new P0 series has to pay a visit to the test track as well. In Visola, 4 kilometers away from Milan Malpensa Airport, lies the wet test track, the Campo Prove. The site covers 250,000 square meters and was opened in 1971. Today, a new P0 series is being taken for a spin. The Tyre is fitted to a Porsche 911, the manufacturer's most iconic sports car. Porsche was the first manufacturer to order custom-made tires from Pirelli. The car maker had specific ideas about what the driving characteristics should be. Superb handling, precise steering, and safety reserves in the event of aquaplaning. Mattia Nicastri has been a test driver at Pirelli for 2.5 years. The developers swear by his judgment.
Humans have so many sensors in their body, and when they're trained like our driver, they deliver the best test results. Nothing has sensors as good as the human body, better than any machine.
Straight from the dry road to the wet test track. Test driver Mattia immediately accelerates the sports car to around 200 kilometers per hour. Tires account for a large part of the emotional driving experience, and yet they're neither a status symbol nor a lifestyle product. Marketing them isn't easy, but Pirelli has always been very innovative in communication. From the beginning, Pirelli has engaged outstanding artists for its advertising campaigns and thus found its very own Pirelli style. One of the cultural treasures, however, is a calendar. Supermodels and actresses were photographed for the famous Pirelli calendar. Laura Riboldi is vice director of the Pirelli Foundation. She exhibits everything to do with the company's history here. Laid end to end, the exhibits would measure 3.5 kilometers.
The calendar is naturally a part of the Pirelli story too. The first calendar was published in 1964. This one here is from 1965 and is the work of Brian Duffy, the greatest photographers of their time, like Peter Lindbergh and Annie Leibovitz, have collaborated with us on the calendar.
Only famous celebrities and selected business partners receive the coveted collector's item. Today, there are 12,000 copies to be distributed. This exclusivity and the famous names involved in its production has given it cult status. Back to the test track in Visola. Test driver Mattia propels the P0 through the slalom course. Over 5,000 test drives take place in Visola each year. The tire seems to respond well on a wet surface. Andrea Vergani checks whether the first test runs have left any signs of wear.
Mattia, how did the tests go?
Good. The level of grip is very high and it responds well even in the wet.
Better than the previous model?
It's well balanced.
We're on the right track?
I really stepped on the gas. It runs really well and we're really strong compared to other tires too.
Let's start the next tests. Sounds really positive. I'm satisfied.
Perfect.
How does the P0 behave in aquaplaning situations? If the grooves in the tread aren't perfect, the tread pattern has to be fine-tuned. Test driver Mattia attaches a GPS to the car, and outdoor test manager Enrico Di Giacomo installs a tachometer.
It's actually quite a simple device. There's a sensor here that counts the number of tire revolutions over a set time. The higher the number, the faster the tire is rotating. So we have both the speed of the tire and the speed of the car is calculated by the GPS. If the tire is no longer rotating, but the car is still moving forward, the tire has lost contact with the road surface. And that's exactly what happens during aquaplaning.
Aquaplaning occurs if the tire is unable to displace the layer of water. What happens during the test exactly?
We measure the angular velocity of the inside tire, and I notice when accelerating if the steering isn't responding properly and I'm losing control over the car.
Can the P0 prevent aquaplaning for as long a time as possible? Mattia heads for the test pan, 150 meters long, filled with 9 millimeters of water. The tire has to expel the water through its grooves in order to maintain as much contact with the road as possible. The sophisticated tread design provides for optimal grip.
I really pushed it. The tire behaves in a very safe manner, even for an average driver.
Mattia checks the tread pattern once again with the head of the testing department, Andrea.
The new tire does in fact offer greater safety in aquaplaning situations. I hope it still works at full power too.
Yes, that's our goal. We're on the right track.
Good.
Again, driver safety is paramount. Every tire carries a great responsibility.
When I'm out, I'm always checking to see if other people's tires are okay, if they have old tires on their cars or the wrong ones for the season.
We're always looking at tires.
Whenever I'm stuck in traffic congestion, I take a close look at the other driver's tires.
It performed well on the sports car, Now the P0 has to pass the same rigorous tests on a sedan. Back in Turin, where the P0 tires are being produced, the tires have covered a distance of around 2 kilometers through the factory in the process. Now, they've arrived at the intermediate warehouse, soon to be set free, to conquer the streets of the world. Something made possible thanks to all the workers pulling together. They propose ideas for improving processes and have a hand in developing new strategies too.
When it comes to the manufacturing process, we're talking about a machine that has to perform flawlessly. We've developed a model taken from Formula One called Pit Stop. This enables us to prepare for the new requirements of each make of car as quickly as possible. We got the idea from Formula One.
Like during a pit stop, all of the processes are perfectly synchronized. Approximately 100 constituents, some of which you wouldn't expect to find in a tire, have to be fused together in order to eventually create a world-class tire. The P0 has completed 50 different tests, both in the laboratory and on the test track. Now it's finished, and countless cars will soon be taking to the streets, fitted with the ultra-high performance tire from Pirelli.